Good evening. I'm Mary Holt, current president of the Shebig Island Historical Society. Welcome and thank you for joining us on Zoom for the Historical Society's Ellsworth Miller Memorial Lecture Series, established by Cap Leonard. Hi, Cap and Jane. The Board of Trustees offers sincere thanks to Cap for his continued generous support of the lecture series. Also worthy of great appreciation is my buddy here, facilitator of our Zoom, Richard Hackle. Those who wish to support the efforts of the Historical Society may donate online at shebighistory.com. Before commencing with the lecture, I wish to acknowledge and honor the Indigenous people who were first to inhabit Shebig, forage its fields and forests, and fish its waters. Questions relative to the lecture will be addressed during the lecture, but we ask you to type them in your chat box, addressing the chat to everyone. Tonight's lecture, Preparing Coastal Communities for Sea Level Rise, will be delivered by Gayle Bowness of Gulf of Maine Research Center. Gayle manages the Municipal Climate Action Program through the Climate Center at GMRI, which engages coastal communities in better understanding local sea level rise impacts and provides them with knowledge, skills, and tools to develop community-focused and data-driven resilience plans for coastal flooding. At this time, it is my pleasure to introduce Gayle.
Thank you so much, Mary, and so great to see all of you joining this evening from online land or off. And yeah, as Mary said, I would love to have a bit more of an informal conversation with you all tonight. I can bring this perspective of sea level science, but you all hold the local knowledge, which when you pair those two together, it's a really powerful thing. And that's what's going to help us to prepare for the future. So I know I will pause and make space for you all to share and might have some specific questions. But also, if you have questions of me, as Mary said, just put those in the chat and then she'll be monitoring that and let me know when to pause and to answer your questions. So just to encourage a little bit more of a dialogue this evening. All right. Can you all see this fine? All right, super. Yeah, so a little bit of a challenge for me today too is to think about the historical perspective of sea level rise, being this is a presentation with the Historical Society. So I wanted to start a little bit with that. And again, this is where your local knowledge comes in. So I found some great photos through the Maine Memory Network that were shared by the Maine Historical Society, showing different photo or kind of locations around Shebig Island. Quite a while ago. So here's one at Littlefield's Landing in 1920, and then another at 1940. And you all will have to correct me. I think this is the Stone Pier. Is that correct? That area? Maybe. All right. Well, anyways.
Yes, it is.
All right. Awesome. Thanks. Because I do know that that is a hot topic of conversation when it comes to an area that's vulnerable today due to flooding, and that's going to need some great thought to think about how it can be resilient into the future. So these two photos, to put them in context of sea level, taken in 1920 and 1940, if you follow those years up, I'm going to use my fancy annotate tool. So we've got 1920, that area, in 1940. That is not very graceful drawing, but you can highlight those places. You can see that the sea level trend hasn't changed an awful lot, and this is global sea level. So around the globe, we've been measuring sea level using tide gauges for over 100 years. We've had the tide gauge here in Portland since 1912. And so if you throw all this data in together, this is showing us as a globe what's been happening with sea level. And if you follow that line up into more recent decades, here you can see that the trend really starts to increase. And especially in the past couple decades, that trend is increasing at a greater rate. And when we're talking about changes on a global level when it comes to our climate, it's that rate of change that's really key here. So that's something that we're keeping an eye on. This blue line, just for reference, this is when satellites came into play for collecting data, kind of in the early 1990s. And this data reflects the same kind of trend line that we were seeing from water level monitors. All right, let's get rid of those. All right, maybe, oh, I'm sorry, I did annotate and it kind of, there we go. All right, now I can move my screen. So what impacts of sea level rise have you already seen? So we've already been in the midst of sea level has been happening. It's been rising since we've been recording this data. So I'd love to hear from you all if you want to take yourself off of mute and share some stories of sea level change that you've observed in Chesapeake or perhaps elsewhere, or you could put that into the chat box if you're more comfortable with that.
Well, I'd be happy to share that we had a camp down on the shore below where my house is now. And we have pictures of my grandparents standing on a porch there. We have pictures of a smaller porch when I was a kid. And eventually we had to take the building down because of erosion. And now with the last storm, it would have taken out half the living room if the building was still there. Mm-hmm. So there's a good example.
Wow, thank you so much for that story.
Well, down in front of our house, high tide used to be at the bottom of the ledge. Now it's nearly 2 feet above that level at mean high.
Great, thank you. Apologies, I can't see who's talking with the way my computer's set up. So keep on going if you've got a story.
So in the last storm also, which was what, December 23rd, our shorefront property, which has a very large clam midden within it, about a third of that midden was intruded by the high tide, the super high tide, and took it away, took it back out to sea. So that was that had been untouched for decades, and this storm really came up big enough to take that stuff away.
Great. Thank you all so much for sharing those. And if you do have additional stories, you can drop those into the chat. Collecting this local knowledge is really important because it can ground truth, the data that we're collecting about our environment or the projections that we have around what different sea levels would look like in different areas can ground truth like those models. So I'll share a bit more at the end of the presentation, how we're collecting some of that local data in a more formal way, but again, invite you to drop some of those stories into the chat. While I was getting ready for tonight, I did some Googling and saw this great photo from the Stone Wharf. I think this was taken about a year ago today during a high tide in January. And I think I remember there may have been a storm event associated with this date because I was out and about in Portland in a pretty nasty weather around this time. Water Reporter is a program run by Friends of Casco Bay, and they've got a great tool for you to snap photos to share with them kind of ecosystem health as far as it relates to Casco Bay. High water or storm events is one of those. Also looking at algae, pollution, runoffs, ocean debris and whatnot, but a great resource and great program supporting better understanding our environment. And also mention other programs that other organizations are offering kind of throughout this presentation too. And just so you know, on the backside, all of us are collaborating and supporting each other through these programs. So it's a great collegial space of organizations in Casco Bay. And then I also stumbled across this. You guys have been doing quite a bit of work. In particular, your elementary school students were. These may be high school students by this time. And I will follow up this talk as well and dropping with an email with links, or Mary will. This was a really great project that Bev Johnson's students did in 2011. Her elementary school students interviewed folks around the island and also compared old photos with new photos that really showed environmental change over time. So you guys have been capturing a lot of these stories. Anyways, and I think you've just got some really great resources to continue to explore and to share. So let's dig into kind of the future. How much might sea levels rise? I'm going to be running through quite a bit of data and some graphs, and in part, I want you to not feel intimidated when you see these data and graphs. So I'll spend some time explaining what the data means, and please feel free to ask questions. Again, drop those in the chat, or if it's easier, just unmute and pipe up. But I'll pause too to make some space, because I'd love for you guys to feel comfortable when you see climate data. So this is looking at global data and looking at the inches of sea level above kind of a baseline that we're taking into consideration of being the sea level in the year 2000. So when we're talking about sea level rise, it's all in relation to what the sea level was recorded in the year, year 2000. So boop, right over here. So we've looked at, you can see the sea level change from 1970 to 2000, and then we've observed this change increasing, and then we can extrapolate because of this trend line. This is what we can project the data to be moving forward into the year 2050. So that's how we're calculating, or how scientists are calculating what sea level projections will be into the future, is looking as to what we've seen happen in the past and looking at those increasing trends and applying them into the future. But sea level doesn't just happen like filling a bathtub. The ocean water is not flat. It's actually kind of pools up higher in some areas, dips down lower in others. And that's really driven by the ocean currents and the tides. So here in the Gulf of Maine, with the you can see kind of the upward swing and really the difference in color between the red and the blue here, showing us the Gulf Stream. And that's really pushing water up into the Gulf of Maine and can create some pooling. So we have more water, or higher water levels here in the Gulf of Maine than the average global water level. Other contributors to kind of why sea level may be different is due to in some areas, the land is rising as ice melts. It's taking that pressure, that weight off of the land, and the land is rebounding due to that. In some areas, the land is sinking. We're still experiencing a little bit of land sinking, nowhere near the amount that's being experienced here in the Gulf of Mexico. Also here in the Gulf of Maine, again, those ocean waters, or the ocean currents, are pushing water into the Gulf of Maine and causing water to pool here and those sea levels to be higher. So what does that global trend then mean when you think about the Northeast? We're actually going to experience more sea level rise here in the Gulf of Maine than the global average, because of that land sinking and because of those ocean currents pushing water here into the Gulf of Maine. So the blue is showing the trend line for the Northeast of what we can expect for sea level rise. So you can see from the year 2000, which again is kind of our baseline, in the past 20 years, we've had about 5 inches of sea level rise. But in the next 30, we can expect at least another 10 inches of sea level rise by 2050. And for context, that 10 inches of sea level rise in the next 30 years is about the total amount of sea level rise that has happened in the Gulf of Maine in the past 100 years. So that rate of rise is really increasing. So this graph is showing us the different kind of sea level projections that we have coming out of thinking about the major contributors to sea level rise. And it's rising because ocean waters are warming and ice is melting, but that's happening because carbon and other greenhouse gases are being emitted into the atmosphere. So these different colors are showing us different scenarios based off of how much carbon and greenhouse gases are being pushed into the atmosphere. The higher projections assume that as a globe, we all continue to emit greenhouse gases on the same trends that we have been today. These low projections assume as a globe that we stop emitting CO2 and greenhouse gases today, essentially, and start to use carbon sinks to absorb a lot of that carbon. So likely the scenarios that we're going to expect are somewhere here in the middle. So I wanted to show you guys all of that data just to let you know how, or in a minute, how it's kind of played into how Maine is thinking about sea level projections for us here. But just one more thing to note, you may have heard around like the Paris Accord that came out several years ago, the Paris Agreement, on how much we want to aim for to make as far as global warming, to make sure that we don't go over a specific temperature barrier. And the rationale around that and how it relates to sea level rise comes down to how stable are our ice sheets. So thinking about Greenland and Antarctica as being the major contributors of water to sea level, and they haven't contributed very much yet, but their potential to contribute is really great. But how stable are they? These are some of the questions that scientists are exploring. So if we keep our global warming to 1.5 to 2 degrees, the amount of sea level or melt from Antarctica is pretty much on the same trend. But as soon as you go up to 3 degrees, you can really see we reach this tipping point for Antarctica, and we'll see a lot more ocean melt, or a lot more land ice melt, and contributing to those ocean waters. And again, that would be if we continue on that trend of emitting carbon and greenhouse gases at the same rate that we are today. And so when we talk about sea level rise, we often talk about adaptation actions into how can we adapt to having these increased levels of sea level. But we also can't stop talking about mitigation. Mitigation means how do we reduce our CO2 emissions? That would be things like electrifying our homes, using green energy sources, solar or wind, and reducing that kind of carbon output from our homes, from our cars, from our communities. So mitigation is important for us to not have this unstable ice sheet situation happen in Antarctica and prevent that 3 degrees of warming. And why that matters, this is a question that gets asked often, so just to share this, is how much potential of water is there in the ice that we have in Greenland and Antarctica? So Greenland has contributed 1.6 inches of sea level to the oceans, but it could contribute, if it all melted, up to 23 feet of water. Antarctica has only contributed 0.2 inches of water so far, but it could contribute up to 187 feet of water. So we'd clearly be living in a very different planet if this were to happen. And if you want to see what that looks like, you can Google what would the world look like if all the ice melted. And there's some maps there. It's nothing that's going to happen anytime soon. That would be a futuristic lesson into like the year 500 plus years from now if we continue to emit carbon on the same trends that we are today. All right, I'm going to pause there because that was quite a bit of data before I jump into how have we like digested this as a state and what are we like recommending communities to do. So if anybody has any questions, please feel free to either unmute yourself or drop it into the chat box.
I noticed that the Antarctic is noted. How about the Arctic? What's its contribution?
Yeah, great question. So the Arctic, if you look in, let me try this annotate tool here again. right up here in the Arctic. Most of that is actually ocean water. It's the Arctic Ocean, not land. Greenland would be like the land in the Arctic and some of northern Canada here too. Sea ice is not a contributor to sea level rise. So when sea ice melts, it's the same as like your glass filled with ice cubes. If you set it out in the sunshine and those ice cubes in your glass were to melt, that water level is going to remain the same. If you add more ice or add more water, then the water level goes up. So sea ice in the Arctic is not a contributor to sea level rise. Great question.
Great answer, thanks.
Right. Any other questions? And if you think of them later on, feel free to drop them in the chat too, or I can take them afterwards. All right, so how do we take all that complex data and kind of digest it into what do we do about it? So Maine's Climate Council, when that came out when Janet Mills became governor for this state, the Maine Climate Council brought together the latest sea level data, which came from this report from NOAA in 2017. And they looked at all those local projections and produced the Maine's climate action plan. And out of that climate action plan were some recommendations for what Maine should do. And those were actually committed to law, I think last summer. So we now have like a legal mandate as communities as far as what we can plan for. And I can tell you how like amazing it is that Maine actually went to this step to give us these recommendations. I'm often on calls with folks who are in like similar roles as I am at different organizations in other states who don't have this recommendation as a state as far as what to plan for. And so much of their energy is spent on that question. How much sea level rise does this community need to plan for at this location? And they have all sorts of processes to try and determine a specific scenario that they want to ensure that they're planning for. And it takes an awful lot of time and an awful lot of resources. And there's very finite resources when it comes to climate planning to start with. So I'm just really thrilled that as a state, we've kind of taken that step out. And instead of starting with that question, what to plan for, we have that already. So Maine has two tracks. One is commit to manage, and then prepare to manage, looking out to 2100. So for 2050, we're committing to manage for 1.5 feet of sea level rise, but we'll be prepared to manage for up to 3 feet. And the difference between commit to manage and prepare to manage, you can think about it in two different ways. One being, is this a place where would be really vulnerable to waves from storm action? If it's like a waterfront, ocean exposed property, storms could be considered on top of that 1.5 feet. So maybe you want to prepare for that 3 feet in that specific location. And then the other example is this specific infrastructure or property of high importance for our community? And so things that could fall into that category would be hospitals, schools, key transportation routes, emergency evacuation routes. For you all, be your ferry docks would be of high importance. So for those, I think you'd also want to follow the prepare to manage track, just to ensure that you're being kind of as cautious as possible as you're preparing for and building resilience to sea level rise. By the year 2100, as a state, we are committed to managing for an additional 4 feet of sea level rise on top of the levels in 2000, but be prepared to manage upwards of almost 9 feet of sea level rise. All right, any questions on that before we hop into what that looks like? Okay, all right, we're almost to some maps. So let's think about what is the impact of 1.5 feet of sea level rise, because it doesn't sound like a lot. But 1.5 feet of sea level rise will bring us from these flood events that we were experiencing about 3 times a year in the year 2000 to these events happening upwards of almost 150 times a year by the year 2050. And again, on that kind of commit to manage track, 4 feet of sea level rise, these flood events are going to be happening on a daily basis. Another way to picture what 1.5 feet of sea level rise is just to think back a little bit to December 23rd, right before the holidays. A storm came through and it brought a little bit better than, or right around like 2.5 feet of storm surge. You can see right here, this blue line is showing us the predicted sea level for the day based off of the NOAA tide gauge that's in the Portland Harbor. The green line is showing what that tide gauge actually recorded that day. So you can see that we were expecting a tide of 11.3 feet, which would already cause some pooling and some flooding in low-lying areas in Portland. But with that 2.5 feet of storm surge, it brought the water up to 13.7 feet, which is roughly what we could expect 1.5 feet of sea level rise to be. So if you think about where you saw water on December 23rd, that's where we're going to see water during our high tides in the year 2050 without storms, without wind, without rain, just on a sunny day.
Gayle, if I may make a comment. It turns out that on the 23rd of January, the tide graphs show exactly the same thing with 2 feet of observed tide higher than at high tide and at low tide for that matter too. So this is not just a one-time thing, but it's happened twice on the 23rd. It makes me nervous that we're in the year 2023, and I hope that's not some kind of sign.
I hope so too. Yeah, my colleagues and I we've been looking ahead to the predicted high tides this year because we want to go out and monitor, encourage other folks to do so too. And they're all happening on holidays as well, which is interesting. Christmas Day, President's Day, July 5th, so kind of close to a holiday. So yeah, 2023, there's something going on with that.
Yes, it's the problem with the people who make the calendars, because why do they plan these storms on days that are going to be holidays?
Yeah, I know, really inconvenient. But yeah, you make a really great observation that we do have these like 2 feet of storm surge happens kind of not routinely, but it's not uncommon. And if it happens when our predicted tide level is going to be lower, like say it can, like our high tides can be as low as 8 feet. The average is 10. We're starting to see increasing amounts, like as sea level rises, those high tides, they're all rising with it. So the frequency of us having a predicted high tide of more than 10 feet is just going to increase. So if we have more than 10 feet of predicted tide and a 2-foot surge comes through, then we're going to be experiencing some flooding, especially if there's a storm and there's a lot of wave action. It could result in some damage, some erosion. So we're increasingly becoming vulnerable to these smaller storms that are coming through. So that was the bad side of that. There is a good piece to our tides, just to keep in mind. Because we do have this high tidal variation in Maine, anywhere between 8 feet to 12 feet between our highs and our lows. Down east, it's up to 15 feet. From Nova Scotia, it's up to 55 feet up there. So where you have these like large tidal variations, whenever you're at low tide and a storm comes through, you're not going to feel those impacts. The story around that is that you don't hear us talking about Superstorm Sandy here in Maine. That had a storm surge of, I think it was 4 to 6 feet when it got to the Gulf of Maine, but it hit us during a low tide. So instead of seeing low tide that day, we just didn't see the tidal level go down. So because it didn't happen during that high tide moment, happened during like the 12 hours that we were in the basin of our low tide, we did not experience flooding when Superstorm Sandy came through. So we have this built-in kind of protection or resilience due to storms because we have this tidal variation. In more southern locations, when you get into like kind of mid-Atlantic and down into the Gulf of Mexico, their tidal variation is like 1 to 2 feet. So they're vulnerable to these storms all the time. They're always going to have an impact. So we're pretty lucky to have these high tides here in Maine. All right, so I think I'm about to hop into some maps. Yep. All right, so I took screenshots of an interactive sea level projection map. And again, I'll share that link with you so that way you can zoom around it and zoom into different locations at your own leisure. I also didn't want to test my internet while on a presentation, so just screenshots today. And we'll start with kind of what you would expect to see when you just look at a map of Chesapeake. I'll then zoom in and we'll do kind of the south end and then the north end just to get a little bit more detail. So this is what you would expect to see at, say, like a 8 to 10 foot high tide. This would be a 12-foot highest astronomical tide, which is what we can experience now without any storm surge here in Maine. This is with 1.5 feet of sea level rise. So this is what we're planning for and committing to planning for by the year 2050 as a state. But we need to be prepared for this. So this is almost, we don't have the exact layers to work with data layers. So this is roughly 3 to 4 feet of sea level rise. So this would be for those kind of high impact areas like your ferry docks, if you have any working waterfront infrastructure, if there's any roadways that would cut off access to other parts of the island, you would want to plan for amount of this level. And then, because it's interesting, not likely to happen, but by the year 2100, this would be almost 9 feet of sea level rise. So you guys have a fair amount of high land, but by nature, we tend to settle next down to the water. I think it's good for the economy, good for our souls to be on the coastline. But it has put us at risk because we do have a lot of infrastructure that is there. All right, so I'm going to zoom in a little bit. So we're down on the south end of the island. So this is what you would expect to see at like a low tide. This is that highest astronomical tide. So this is pretty much what we had last week on Tuesday. There wasn't any storm surge and it was about an 11-foot tide, so pretty close to this. 1.5 feet of sea level. So we need to plan for by 2050. This is what we need to be prepared for those areas of high importance to communities. And this is kind of the worst case scenario in the year 2100. So if you do have infrastructure that you're planning out on kind of an 80+ year time frame, you may want to consider this scenario. So to pop to the other end of the island, so low tide. This is one, so the highest astronomical tide, sorry. So this is what we can experience today. This would be that tide in 2050, so what we're planning for. But what we need to be prepared for, particularly with storms. You can see you've got quite an exposed coast there, so the wave action would be quite great during a storm as well. And then worst case scenario in 2100 for those areas of like longevity and or high importance to communities. All right, so I'll pause there and I'd love to hear from you all if there was anything in that kind of you found surprising or shocking, or if there was any pleasant surprises, which could be part of this as well. And I'm happy to try to navigate back to a different map if needed.
Hi there. I have a question.
Yeah.
So it's clarify for me, please. So even without ice melt,
Yes.
with all these other things you're talking about, with the sinking land and the warm waters coming in and the global impact, the ice, I mean, the ice sounds like it's going to melt anyhow, but that is sort of like the least, it's only one factor into these multiple problems that the world and should be are going to have happen to them. That's
Yes. Yeah, correct. So these flood maps are showing us what we can see with the current trends of ice melt that we have. It's just once we reach that 3 degrees of warming as a globe, we don't really know what's going to happen. That's a tipping point for ice stabilization for those large ice sheets. And we just don't have the science to quite understand what that model would look like, other than it's not going to be good. So this is like a current science that we're constantly learning from. The 8 years that I've been involved in doing sea level rise work with communities, I've seen the data evolve significantly. And it's unfortunately kind of almost doubled in that time. But the most recent data has stabilized a little bit. So we're definitely, our understanding of what's happening is increasing, but this data is taking into account that current trend of ice melt. Yeah, great question. Erica, I see your hand up.
Yeah, I had a question about, do you have a correlation to this, to the quality of the storms too? I'm not from Maine, from New Jersey, and was in Storm Sandy when a storm like that hit. So what about hurricanes and tornadoes and things that are unlikely? We got an expert, Bill Danielson on the call. What about the overlay of unusual storm behavior on top of this?
Yeah, really fantastic question. And actually, I'll take a stab at it, but Bill, I'd love to hear your response to that too. So far, we can't correlate an increase in the intensity and frequency of storms to climate change in the Gulf of Maine. That said, we do have warmer air, and warmer air can hold more water, which can lead to more extreme precipitation events. And we are seeing a shift in the ocean currents, which can bring in different storm patterns at times that we're not used to experiencing them. And I think a big piece of it too is what we talked about prior, with having these higher tides, smaller storms are having a bigger impact. So it feels more frequent because that impact is greater. But yeah, Bill, if you have anything to add to that, I'd love to hear it too.
Well, I think that the increase in extreme events worldwide is getting greater all the time, because not only can the warmer atmosphere hold more moisture, but it holds more energy, and that energy has to go someplace, and it ends up being expended in more intense storms of all sizes, from tornadoes to hurricanes to these huge storms that have come through here and caused gigantic amounts of rain and so on lately. 2.5 inches of rain on top of all that snow the other day. These are pretty unusual events, and I'm not saying they all have come straight from global warming, but the pushing that extra energy into the air just makes these things more likely all the time. So yeah, you're right. That the data have not shown that Maine is suffering more greatly now from hurricanes than it used to, and certainly tropical events like tornadoes. But the risk is certainly there, and the likelihood, I feel, is definitely greater all the time.
Great, thanks so much, Bill. And I'm just going to use that line of questioning to ask too. We've been looking at kind of maps of island, but there's much more complex impacts to sea level rise when we think about our community and how our community functions, as well as the water coming in is going to have different kind of impacts on our community. So these different complex impacts could be things such as saltwater intrusion, the increased erosion. I know that's definitely something that Shabik has been experiencing, a lot of undercutting of the cliff sides, which is causing land to erode. And then also too, we need to think beyond our community and to think about what does our community need to be successful. And a lot of that is the transportation of goods and services and people. And for you all, that's a reliance on kind of the ferry terminals. So I wanted to zoom in here to Portland. Back a second. And you can see, oh, sorry, I'm trying out this annotate on you guys for the first time. Clicking wrong buttons. You can see the Portland Ferry Terminal there is experiencing flooding with 4 feet of sea level rise. Okay, now I need to get rid of my annotate. There we go. And then to zoom in to Cousins Island, and the ferry terminal, you all will have to correct me here. Comes out, is down at the far end, sorry, of Spruce Point Road. Is that correct? Where the ferry terminal is? Well, I just noticed that there's a flooding that's happening on one of the roads to get to that access point. So just to access where the ferry terminal is there, as well as Cousins Island to the mainland. That causeway is vulnerable to flooding under a 4-foot sea level rise, and then before as well. So just to think kind of how we can't be thinking about sea level adaptation individually as communities. In order for our community to be successful, we also may need to support adaptation in our neighboring communities, and taking on a bit more of a regional approach to support some of these actions may also be beneficial to us as we're thinking about our climate action plans, to think beyond our municipal borders. And then we talked about storms and storm frequency, storm intensity, and just how we are also experiencing that intensity more now because of this higher water, that these smaller storms are having more intense impacts. So just a couple photos of storm impacts here along the Portland coast, along Commercial Street, and the lower left photo is Shore Road and Cape Elizabeth, where the waves were bringing quite large rocks right up onto the roads. I'm not sure if you have all experienced that on Shabik or not, but wave action is also something to take into consideration. Even if there's not a storm, if the water levels are just high, but we've got some high wave action, it can have some increased damage too. So what do we do about it? There's different ways to kind of frame thinking about adaptation. And again, I'm going to focus more on the adaptation side. I mentioned earlier, mitigation also needs to be a part of this conversation because that will reduce our CO2 outputs. But one thing about when we're talking about climate change and these global cycles, sea level rise is on this 30-year kind of system. So the impacts that we're seeing today, our sea level we're seeing today, is because of CO2 and other greenhouse gas emissions from 30 years ago. So it takes 30 years for us to experience the impacts of those emissions, and kind of same in reverse. So whatever we do today to reduce our emissions, we won't see the effects of those for 30 more years. So we're really locked into these projections on a 30-year time scale. And that's why having that 1.5 feet of rise to plan for by 2050 it's most likely something that we can expect to have happen. So in the meantime, we definitely do need to adapt, but for thinking about future generations, mitigation is also important. So in the meantime, we've got some options. Could be as simple as opting to not do anything. So no response is definitely an option. And often that can come in combination with a response to perhaps retreat. So maybe you don't do anything in one place, but you're moving those people or goods and services other and keeping that land the same, and or you could return the land kind of back to nature and remove infrastructure that may be there. You can protect. Oftentimes protecting has the intent or the goal to keep the water out. Oftentimes this includes using hard infrastructure or gray infrastructure like seawalls. And also if you're ever, like if your goal is to keep the water out, that may work for a finite amount of time, and that eventually though will fail. The water is going to continue to rise, and that adaptation action will have a lifetime. Accommodation, we can learn to live with water. So a lot of homes, particularly in southern states, and we're starting to see these increasingly in southern Maine, are being raised. Another example of accommodation is some of the development along Commercial Street in Portland are putting in extraordinarily tall first stories and putting in all of their utilities, like electrical and heating and all that up in the space between the first floor ceiling and the second floor. So it's being raised up off the roof, and creating a way for like safe flooding, I guess, on that first floor. And then kind of this last one here too, ecosystem-based adaptation. This is where a lot of energy is right now, particularly in the funding realm. A lot of the areas that flood first are often areas that used to be land. And this would be a great question for the Historical Society. I don't know if you guys have land on any kind of filled areas, or if you turned, or if the community over time kind of filled in marshes or low-lying areas to create kind of roads or kind of more solid space for building. Not sure.
I don't think that there's been any filled in shoreland that's been built on.
Okay, great, thanks. Yeah, so for places where that has been the case, those are the places that are really going to flood first. So for Shabig and thinking about ecosystem-based adaptation, we can think about how has nature always been that kind of first kind of filter or buffer for us, as far as kind of keeping the inland areas safe. So a lot of that comes through like salt marshes or estuaries. Oh, I've got a photo. It's not this one. There we go. So thinking about kind of the role of dunes in keeping beaches stabilized, the role of marshes in filtering the water that's leaving the land, but then also protecting us from wave action coming onto the land. It also creates floodable spaces. So a lot of this kind of restoration of these living shorelines is around how can we conserve what we have and also bring back these places by either like replanting dune grass and or creating ways to catch sediment to support kind of the regrowth of our salt marshes and or to prevent additional erosion. It's also a great opportunity too to do some mitigation actions as well, because salt marshes have been proven to be really high absorbers of carbon. And I think per comparison, like if you were to compare like cubic foot of carbon absorption of a salt marsh to cubic foot of carbon absorption of a rainforest, the salt marsh wins. So there's some science going into right now into understanding kind of the value of Maine salt marshes in absorbing carbon, which is rather interesting. So those are some different ways that we can think about kind of framing, how do we want to approach adapting different locations to having these higher sea levels. Can we stay there? Do we need to retreat? If we stay there, do we need hard infrastructure? Is there a role for nature-based? Is there a role for both of those, kind of in combination? So those are some of the questions that can drive some of that discussion. So some things that the Gulf of Maine Research Institute is doing to support communities in better understanding the impacts of high waters, as well as kind of how communities are viewing some of these questions around how do we adapt, is through citizen science. We're using the term community science. It's the same thing if you're familiar with citizen science. Community is just more open and inclusive. So we have a community science coastal flood project. And through this project, we're looking to answer the questions of what water levels and weather conditions lead to local flooding. So that way we can understand exactly when is high water or a flood threshold going to be reached in specific locations. And then we can plan for that, as well as put out more current flood alerts. So we're currently partnering with the National Weather Service to support them in their flood alerts and kind of weather forecasting. And we're also partnering with the Greater Portland Council of Governments. And I know that they've done a fair amount of work with Shabig in the past in supporting you and understanding your vulnerabilities. And they have a new project to expand upon the work that we've already been doing. So here's an example of the community science project in Portland. We identify coastal flood monitoring sites throughout a community and encourage folks to go to these locations to make observations during high water events, to either look for flooding, look for evidence of flooding, which could be erosion or high water marks such as seaweed or other ocean debris that's been pushed up by the high water. And also to take into account what are the weather conditions happening in this area. So what kind of precipitation is there, if any, wind, if any, kind of wave action, if any, and that's really going to support the Weather Service in bringing these observational data into their modeling. And we also ask questions such as, how concerned are you about flooding in this location? What types of adaptations would you like to see your community use to address? And do you feel your community is prepared for action to address flooding? So some questions to help inform community planners and community leaders in gathering that input from the community as a whole to inform their plans. So through this Greater Portland Council of Governments project, we'll be expanding this work to every coastal community in Cumberland County, including Shabik. So we've already been in touch with Vika, and we'll be working with her, as well as maybe some of you, to identify coastal flood monitoring sites this spring. And my colleague Abigail will come out to collect the data in order to create the resources that you need in order to participate. So we're really excited about that project. Oh, yep, here's kind of what that looks like in action. So this would be a highest astronomical tide down in Portland along the Portland Pier. And you could see collecting data is as simple as using your smartphone to take some photos, upload it to the website, and then we've got some multiple choice questions for you as well. Another project that we're working on, this one is in collaboration with the Island Institute, and I know that Shabik has been working with Abby Roche there. And this one is to support communities in thinking through how do we, like, what's a framework for planning and for community involvement in climate action and adaptation implementation projects. And to start this work, we really come back to, like, what is the heart of your community? As I was saying at the beginning of this presentation, local knowledge is so important in order to understand the problems, but also to find the solutions. And that local knowledge can come through stories, but it also comes through values. So we do a values-based exercise to kind of bring together, like, the diverse community values from different community members, and to come to some shared values that we can use to drive a decision-making process. And through running through different climate scenarios, we use values to support how community members would choose different resilience strategies to address those scenarios at hand. So for example, if your community really values kind of access to nature, environment, and there's a scenario around increased kind of road flooding due to sea level rise and or a storm that came through, perhaps a resilience strategy could be around building out a natural buffer next to that roadway instead of using riprap, would be a way to kind of pair community values with those different resilience strategies. So we're currently working with coastal communities. This is a workshop we hosted on North Haven in December to do this work. And again, we're working with Vika to schedule one of these on Shabig. So really excited to get to come out to you guys someday soon. And then I wanted to share again some other projects that are happening or other resources that you have, because I think it's just a really exciting time for the state. There's a lot of organizations that are supporting communities in this work. And as I mentioned, we're all working together collaboratively to support each other kind of on the back end. So it's all really connected. So right now, the Greater Portland Council of Governments has this new project called Climate Ready Casco Bay. The community science work that GMRI is doing is a key piece of their community engagement strategy for that. So we're collaborating with them on that project. And they'll also be building off of this resource that they already provided and worked with Shabig on developing in 2016 around your sea level vulnerability assessment. As I mentioned, there was a new sea level report in 2017, so they'll be updating the data through this Climate Ready Casco Bay and updating these great resources that you already have to be more relevant and in line with the Maine Climate Action Plan. And then we're also collaborating with the Island Institute and their funding through the Community Resilience Partnership through the Governor's Office of Policy Innovation in the Future. It's a mouthful. I'm trying not to do acronyms though, but just a really fantastic program that I think has really activated a lot of communities throughout the state. And again, is an opportunity to create some cohesion through regional partnerships too, because that's also kind of a perk of working collaboratively with other communities. You can actually access and unlock additional funds through the Community Resilience Partnerships program. All right, well, I kind of spun through quite a bit there at the end, but that's all I have for you. And oh, 7:59, I'm like right on time, but happy to take any questions.
Gayle, I'd like to just bring you and others perhaps up to date a little bit on things that have happened in the last few days, actually.
Oh, absolutely.
Carol White, one of our select persons, has pulled together a climate action committee for Shabig, which consists of about 6 of us at the present time. Julia Main, Erno Bonebacker, who's online with us now, Eldrick Terrell, Tracy Calder, and Eva Newman. And we're looking for other people who would like to work together on this team. We're looking for another high school student as well as community members. So we've only had a single meeting, but we're off and running. We have several really important, we're focused on several really important issues to deal with, starting with groundwater situations, the greenhouse gas, an inventory of what our emissions, and transportation issues, especially those things. And as I say, we're looking for other volunteers, so please let us know if you'd like to be part of this. And Erno, if you're still there, perhaps you could say a few words about the proposal that went in at 9 o'clock this morning to the Casco Bay estuary team.
Partnership, yeah.
Erno, are you there or? Well, he may have gone off, but we've requested a tide gauge to be installed at Shebig to keep track of the moment-to-moment tidal changes. This would be available in real time to everybody who wants to look at it. And it would be not only a really useful tool for everybody from the CTC people and travelers on the ferries, to also for educational purposes, to keep people's awareness high about the changes that are taking place as we go forward during these times of global warming. The end.
I finally figured out how to unmute.
Oh,
Yeah,
okay.
now we
And
can see each other a bit better too.
in the simplest terms, having a tide gauge will help all of us when we're going to the ferry to decide whether we have to wear our boots or our uptown shoes in high water. And I think there's going to be lots of other things that will be sort of filtering out of that. And I'm really looking forward to bringing these issues to the community in a very real way.
Well, that's just so fantastic. And thank you for the update and amazing work that you've all been doing in the past 3 days. Yeah, and just how it's connected. I think, Arnaud, you may be working with my colleague Hannah Berenis on that
Yes.
tide gauge and installing that. And that would be supported through the community science project as well. We're working on kind of back end data kind of connections, so that way when folks go out to make observations, and when you input your data, it will also tell you what that tide level was for that based off of the closest tide gauge. And if you have one of those devices on island, that would just be a really fantastic and accurate connection there. And yes, I would love to connect with your climate action committee. I think that we could support you guys in getting some projects off the ground.
We look forward to shamelessly exploiting all of your resources and talents.
Thanks so much, Arnaud. I always enjoy working with you.
Gayle, this is Phyllis Brunner. I'm calling in from Seattle, and I have a place at the west end of the island. I really enjoyed your presentation. It's fabulous. With all the data and all the variance in the data, how are communities setting design elevations for infrastructure around the state of Maine? Is there a process that's in place that's happening? Have those numbers been set? I'm thinking of the stone pier and then structures around the island, like old piers that we might be replacing. How is that process going?
Yeah, great question, Phyllis, and thanks for tuning in from the West Coast. Yeah, so as a state, we have set to expect 1.5 feet of sea level rise by 2050, expect 4 feet by 2100, but be ready for 3 feet by 2050 and upwards of 9 feet by 2100. So again, that depends upon the type of infrastructure, what you should be preparing for there. A great place to start is just through doing kind of the vulnerability assessment using the existing kind of maps that we have, and to note that the Department of Transportation has just contracted out to create a much more improved and more accurate map viewer for different sea level and storm projections for the state, but that's hard work, and I don't think we will have that accessible for the next 18 to 24 months. But it will be much more updated data. So we've got some pretty great data right now through the Maine Geological Survey. That's the data I was sharing with you earlier. So once you know kind of what those projections are for specific locations, and how you as a community are thinking about prioritizing where to take action first and thinking about which type of action you want to take, then it would come into bringing in different expertise, such as different engineers or architect or landscape architecture firms to get that kind of on the ground schematics for what different actions could happen there. So it would be kind of the next step once you know where you want to take action and what your basic goals are for that location.
Thank you.
Yeah, you're welcome.
Erno again. Another thing that's in the wind is that the Casco Bay Estuary Partnership has contracted to develop a hydrodynamic model for Casco Bay, which will provide 72-hour forecasts of things such as water level, waves, currents, water temperature, salinity. In effect, replicating what the Weather Service does in the air in the water in Casco Bay. And I think we haven't even begun to appreciate the potential uses of this model in deciding when to go boating, when to go swimming, you name it. And the draft model is planned to be rolled out next summer, and the validated final model to be rolled out in the summer of 24. So this is happening soon. And I expect that the tide gauge, if we get the funding, will contribute to the data supporting the model. I think it's very exciting.
Yeah, thank you for sharing that project as well, Erno. Yeah, Casco Bay Estuary Partnership is up to some very exciting things. One piece of that project that I think is very cool is that they're currently scoping that out with end users. So that way they don't just put out a scientific model and then have to teach us how to use it. They're looking to design it based off of how we would want to interact with and use data. So it's a very user-centric approach, which is really exciting. So lots of things to come in the next couple of years. Great. Well, I'll be available for questions. I'm sure Mary will share my email with you all. I'd be happy to answer any questions you have and pass you along to resources or folks that might have an answer better than me as well. I'm happy to be a connector too. And I'm also really looking forward to doing continued work with you. So thanks so much for joining this evening.
Well,
Thank
thank
you.
you, Gayle, for a most informative presentation. I might have nightmares. Sincere thanks to all of you who joined us this evening. We all have so much to think about, and hopefully we might have some volunteers among us who will join Bill and Erno and Julia, Eva, all those who have volunteered for a very important committee. Please consider joining us next month on Zoom at 7 p.m. on February 27th, when photographer Richard Hackle will share some of his early photography and how it has led up to the work he does today, depicting a history of transitions and stability. So I thank you once again, Gayle. Thank you all for joining us, and we hope to see you in February.
Yeah.
Stay well.
Thank you all.
I love seeing you all on
Yeah,
Zoom.
it's great.
It's wonderful.
Thank you all. It was wonderful.
Yeah, it was really good. Nice to see everybody.
Excellent.
Nice to
Yes,
see
thanks
everybody.
for seeing
Great to see
everyone.
you. Bye-bye.
Very
Be
nicely
well and
done.
keep your feet dry.
Yes.
Good, good.
Got my boots
Thank
on.
you.
Thank you, Gayle. We look forward to
Great,
meeting with
Gayle.
you.
That was great.
All right. Thank you all so much. Have a great evening.
Thank you.
You
Night.
too.
Right.
Night. Leave.
Okay.
All right.